Welcome, fellow Round Rock ISD teachers, to this explainer. Today, we're mapping out our 5-day first grade science unit Avanzamos, or Setting Up for Science. If you're a busy classroom teacher gearing up for the week ahead, you are absolutely in the right place. We're going to get you totally ready to teach this unit with confidence, even if you don't have a background working in a science lab. Let's take a quick look at our roadmap. We'll start with unit foundations and TEKs, move into enduring understandings, hit day 1 with real-world STEM, jump into days 2 through 4 for descriptive investigations, and wrap it all up on day 5 with the engineering design process. All right, section 1, unit foundations and TEKs, the destination. We're targeting TEKs 1.1a, asking questions based on observations, 1.1b, planning and conducting simple descriptive investigations safely, 1.2d, evaluating designs, and 1.4a, explaining how science helps others. In plain language, we're focusing on getting our first graders to ask questions based on things they observe, plan and conduct simple investigations safely, evaluate if a design actually works, and explain how science helps people in the real world. By the end of this unit, student mastery looks like a child transitioning from just passively watching the world to actively asking, why did that happen, and how can I test that safely? Moving right along to section 2, enduring understandings, big picture concepts. So as a teacher, the core science content you need to understand here isn't some complex, high-level physics. It's actually just about helping students recognize universal cross-cutting ideas. We want them recognizing patterns or patrones in nature and understanding cause and effect or causa-efecto. This dual language vocabulary is perfect for making those connections. Let's address a really common misconception right away. Science is not just a list of random facts to memorize. We need to reinforce the correct understanding that science is a practical way of observing how systems connect and function together. Okay, section 3, day 1, real-world STEM, the hook. To hit that TEX requirement of explaining how science helps others, we get to introduce your students to Guillermo Gonzalez Camarena. He was a fascinating electrical engineer who literally brought color to television. You can explain to your kids how his invention helped children learn through colorful, engaging educational programs. It makes the whole idea of an engineer incredibly relatable and real. Now, looking at actual primary source sketches of his design is so incredibly valuable. Kids often have this misconception that engineers just instantly build perfect, shiny things right out of thin air. No way. Showing them these patent drawings proves that great inventions start with a simple, messy sketch, just like the ones they draw in their own notebooks. Next up, section 4, days 2 through 4, descriptive investigations, the process. Transitioning from observing to reasoning on day 2 relies on a simple but super powerful 3-step process. Observo, pienso, por qué. What do you notice? What do you think? And why do you think that? This right here is the core of a descriptive investigation. For your emergent bilingual students, maintaining these sentence stems visibly in both languages on the board is an absolutely crucial support while they work. Students will use visual cues, like a cat drinking or a rabbit eating, to apply that 3-step framework to figure out exactly what animals need to survive. It's a fantastic low-stakes way to practice making claims backed by visual evidence. As a modification for students needing a bit more support, you can provide pre-written observation options they can sort out. Meanwhile, above-level students can be challenged to write out full, complete sentences for their por qué reasoning. By day 3, we build on those basic observations and formalize them into 5 distinct scientific skills. We ask the question, plan the steps, do the experiment, record our findings, and communicate the results to the group. Day 4 puts those skills to the test with an actual hands-on investigation. This is where you'll set up a container with various objects and provide a magnetic wand, or varita magnética. Students will predict which objects the magnet will pick up, investigate, and record their data. Here's a huge pro tip for your setup. A very common misconception is that magnets stick to literally all metals. When choosing your objects, make sure you include non-magnetic metals, like an aluminum can tab or a penny, right alongside magnetic ones like iron paper clips. Let them discover that misconception completely for themselves. A critical point to hit during day 4 is safety. Show your students the specialized tools scientists used to stay safe in the field, like safety goggles, lentes de seguridad, and heat-resistant gloves. Remind them that doing science is incredibly fun for sure, but it requires responsibility and the right protective gear. And finally, section 5, day 5, engineering design process, the application. To kick off day 5, you'll want to finalize your interactive word wall. Here is exactly how you should script this for your class. Introduce ingeniero and say, an engineer is a person who uses science to solve problems. Then introduce the problema as the issue we need to fix, solution as how we fix it, and finally, prototype, the first test model we build to see if our solution actually works. Reinforcing these Spanish terms visually alongside pictures on the wall is the perfect support for your emergent bilingual students. Engineering isn't just a straight line, it's a loop of designing, testing, and improving. Your first graders will analyze a very relatable problem, a rolling pencil falling right off a desk. They'll evaluate different designs to see if they function as intended, and then propose their very own solution, designing a prototype just like a real engineer. By the end of this 5-day journey, your students will have covered vital TEKs, conducted safe investigations, and learned to think critically about the everyday objects around them. As you head into your classroom to teach Avanzamos, ask yourself, how will you use these simple, everyday investigations to inspire your young learners to truly see themselves as the curious, confident engineers of tomorrow? You've absolutely got this, teachers. Have a fantastic week of science.